We are now on a question that has an infinite series, okay? Infinite, right? Now, that sounds crazy that you're going to add a number and add a number and add a number and keep adding forever, right? No, so most of the time you're going to be like, well, if you're adding something forever, the answer is infinity. And that's true sometimes. When is it true? When your ratio is bigger than one, if it's geometric. Okay, if it's geometric and your ratio is bigger than one, then yeah, the answer will be infinity. There is no sum. In other words, it's divergent. Um, if it's arithmetic, arithmetic means there's a common difference, and you just keep adding and adding and adding. For sure, it's always going to go to infinity. All right, but in this case, it's geometric. So we have on our formulas right here the geometric formulas, the summation formulas for geometric, but this one on the side is a summation formula for an infinite geometric series. So this one's infinite. This is the one we're going to be using. And it's very important that we recognize that it says you're going to use this formula only if your common ratio is less than one, but yet greater than one. Okay, so if it's between -1 and 1, you're going to use this formula. What if r is greater than 1? Well, if r is greater than 1, the answer is simply going to be infinity. Okay, so in this case, the r is less than 1. R is right here, the base of your exponent situation. So r is 3/5, it's less than 1, you are able to use it. So how are we going to use this? We're going to start by writing out our a sub 1 term up on top. Okay, let me get this out of the way. So here's a formula. The summation, if you want, you could put a little infinity symbol right there because there's infinite numbers. And up on top, you have a sub 1. So what is a sub 1? A sub 1 is simply plugging in 1 right there. 1 minus 1 is 0. Anything to the 0 power is 1. 1 times 18 is 18. Or you could recognize that this is kind of like the a sub nth rule for a geometric sequence. A sub n, or a sub 1. A sub n equals a sub 1 times a common ratio to the n minus 1 power. The only difference is that you have a k instead of an n. Okay, so what is a sub 1? A sub 1 is 18. It's this guy right here. Okay, and that's only when you have a 1 down here. If you had a 3, you'd actually have to plug in a 3, work out the math, then you would have your a sub 1 term. Um, but if you have a 1, yes, that's your a sub 1 term, or you could plug it in and it'll give you that answer anyway. So a sub 1 is 18. Okay, now on the bottom you have 1 minus r, but what is r? R is the 3/5. So r is 3/5. Okay, and you could do this on the calculator, but if you get a calculator and go 18 divided by 1 minus 3/5, hit equal, it's probably going to give you the wrong answer. I would just simply change the 1 over 1. I would change that to a 5 over 5 and then scratch out the 1. 1 over 1 is the same thing as 5 over 5. Why would I do that? Because now I have a common denominator. Now I could actually subtract 5, take away 3, and that'll be a 2. So what do I have? I have an 18 up on top, and on the bottom, I have a 2 over 5. Okay. Now, this, you could do it by hand. 18 divided by 2/5. I would write it out sideways, horizontally instead of vertically. 18 divided by 2/5. And we know that the division is going to become multiplication as long as you flip that second fraction. So you're really going to have 18 times 5 over 2. Okay. And 18 times 5 over 2, you could multiply first, then reduce, or you could reduce first. 18 divided by 2 is 9, and then multiply your 9 times 5, which would give you a 45. So the answer to this infinite series, this infinite addition problem, the answer actually is the number 45. Find the sum of the above infinite series if it exists, right? So this addition problem, it continues forever. It doesn't have an end. It doesn't say like plus 58 and it stops on 58. No, it goes on forever. So we need to find the summation to this infinite geometric series, if it's geometric. Now, what do I mean by if it's geometric? Well, is there a common difference or a common ratio? Well, if you go 21 divided by 14 on a calculator, I just did that, it's 3 over 2. Okay, 3 over 2. So, and what about 14 divided by 28 over 3? 14 divided by 28 over 3. That's also 3 over 2, okay? So once again, when you go 21 over 14, 21 over 14, that reduces down to 3 over 2. So that's a common ratio. And if you did also, likewise, if you did 14 divided by 28 over 3, 14 divided by 28 over 3. That's really the same thing as 14 divided by 3 over 28, but just let the calculator do it for you. 14 divided by 28 over 3, and that also gives you 3 halves, okay? So the common ratio is 3 halves. And here's the deal. If your common ratio, to get from this number to this number, what do? You're multiplying this by 3 halves. So if you multiplied 28 over 3 times 3 halves, the 3's would cancel out, and 28 divided by 2 would give you 14. If you multiplied 14 by 3 halves, 14 divided by 2 is 7 times 3 is 21, right? So if you multiply 21 by 3 halves, you're going to get your next number and your next number. But the question is this common ratio that you're multiplying by to get to the next number, multiplying by to get to the next number, is this common ratio causing your numbers to increase or to decrease to nothing, right? And of course, because it's greater than 1, 3 halves is 1.5. Because it's greater than 1, it's going to cause it to increase. So this got bigger to 14. 14 got bigger to 21. If you did 21 times 3 halves, or 1.5, that will be 31.5. So that actually gets bigger. So if you keep adding something that's bigger and something that's bigger and something that's bigger, um, the answer is infinity, right? Like the answer is infinity, okay? If you look at your notes, the notes that we have here for the summation formula of an infinite geometric series, we did conclude that it was geometric, and we did have a common ratio of 3 halves. But it says right here, use above formula only if your common ratio is less than 1 and also greater than -1, okay? And obviously 3 over 2 is greater than 1. So you cannot use this formula. Why not? Because you're not going to get an actual sum. If you keep adding something that's greater and greater and greater, the answer is simply going to be infinity, right? Now, if you read the instructions, obviously you're not going to type that into the quizzes. It says right here, if the sum does not exist because it goes to infinity, just type in the word infinity. So type in INFINITY. Boom, you're done. We have another infinite summation problem. And this is geometric again, because it does start with 1, which means that this is a sub 1. This is your common ratio, right? If we remember the rule for the a sub nth rule, it's in that format, a sub 1 first times the common ratio to the n-1 power. The only difference is that right here, it's k instead of n. But yeah, this is geometric. And knowing that it's geometric, you know your a sub 1 term. A sub 1 is right here. You know your common ratio, which is the 2/3. And you could use this formula right there, because your ratio is 2/3, not greater than 1. 2/3 is less than 1. So the ratio is between -1 and 1. So you are able to use this formula. Let's do it. So you don't have a S sub n because it's technically an infinite amount of numbers. You could put infinity right there if you want. S sub n, or S sub infinity, the summation of these infinite numbers is going to be the fraction a sub 1, which happens to be 3 over 1 minus that common ratio 2/3. Again, if you're using a calculator, I would do the simple stuff that we can in our heads without using the calculator. For example, the 1, I would rewrite 1 as 3/3. 3/3 is the same as 1. Okay, 3/3. I'm sorry, not 3 over 1, 3/3. So why would I do that? Because now I have a common denominator, 3 and 3. So now you have a common denominator of 3. You could go 3, take away 2, and you're going to get the answer 1/3 in the denominator. So what we really have here is 3 divided by 1/3. Okay. And if you write that horizontally instead of vertically, 3 divided by 1/3, you could actually easily change that division to multiplication as long as you flip the second fraction. So you're really going to have 3 times 3 over 1, which is really just 3. So you really have 3 times 3, which is 9. And ladies and gentlemen, that is your answer to this summation problem. The answer is 9. Last question here. We have one of the last questions, not the last, one of the last questions. We have a finite geometric series. We're going to find the summation of this finite geometric series. And when you look at your geometric summation formulas, you could use either one of these depending on the information that's provided to you. So I'm just going to rewrite both of them and put them right here. And we're going to use the one that best suits us. So if we want to use the top one, we need the a sub 1 term, which is easily found by plugging in this first number, this first input. You plug it in and work it out. That'll give you your first number. If for some reason you had a 1 right here, then your a sub 1 term would be this actual term right here. But it's not a 1, it's a 4. Okay, so you actually have to plug in 4. So I would maybe in your notes or on your paper write down first number, and it would be by plugging in the number 4. All right, so you're going to rewrite this thing. The first number is going to be the -4 times -2 to the power of, and you're plugging in the 4 for k, and then -1. So this math you're going to do with the calculator. I mean, you don't have to do it with the calculator. You could just say you're going to have the -2 right here to the third power, because 4 take away 1 is 3. And if you think about, let's bring down that -4, the multiplication. If you think about -2 to the third, that's -2 times -2 times -2. That would be a +4 times -2, that's -8. So what we really have is a -4 times this value, which is a -8, which that becomes 32. So technically our first number is 32, okay? So the first number goes right here or right here, depending on which formula you want to use. If you want to use the top one, well, you need to use a sub 1, which is 32. You need to know the common ratio. The common ratio would be this base right here. The common ratio is -2. So you could use the top one if you'd like. If you wanted to use the bottom one, you would have to find, you already know a sub 1, we said it was 32. You'd have to find a sub n. How would you find a sub n? Well, if the first number was plugging in this first number, and then for the second term, you'd have to plug in the number 5. The third term, plug in the number 6 and 7. And then until you get to 10, that'd be your last term. So to find your last number, you'd be plugging in -4, -2, and you'd be plugging in that 10 value, 10 take away 1. Okay. So doing the math right here, you'd have -2 to the 9th power times that -4. So I would do this on the calculator. If you go on a calculator, -2 to the 9th power, and -2, put it in parentheses when you do it. So -2 to the 9th is -512. So this guy is -512, and we still need to multiply it by -4. So -4 times -512 on a calculator gives you 2048. And we just found the last number, okay? So we have our first number, 32, our last number, 2048, and we also have the common ratio r. So you could use the top one, you could use the bottom one. If you wanted to use the top one, you'd have to figure out what n is, and that's really easy to do as well. N will always be the top number minus the bottom number plus 1. So n equals 10 minus 4 plus 1, so n equals 7. So it depends which one you want to use. I would use the bottom one. I just feel more comfortable with it, but if you want, you could use the top one. So the bottom one reads, the summation of how many numbers are we talking about? We just found out it was 7. Okay, so the summation of 7, of those 7 numbers that we don't know, is going to be equal to a sub 1, which happens to be 32, and then minus the last number, 2048. And you still have to multiply it by the common ratio r, which happens to be a -2. And this is all still over 1 minus that common ratio, which is a -2. Okay, so let's begin by doing the -2048 times -2. On the calculator is going to be a positive 4096. So what we really have is 32 minus 4,000, no, plus 4096. Because a negative times a negative is a positive, and it is over 3. So with the calculator, the 32 plus 4096, you get 4128 divided by 3. we get 1,376. So that is the summation of these 7 numbers that we don't even see on this series, 1,376. So if you were to plug in the number 4, get out your first number, 32, plug in the next number 5, get out your next number 6, get out your next number, all the way to plugging in 10 and getting out this last number, 2,048. And then you go back and add up that entire list, it will give you the answer, 1,376. This question, like always, you take the information they give you and you plug it into the formula that you could plug in all your information into. Obviously, we're talking about the summation and we're talking about a geometric series. So you got to look at your summation formulas of a geometric series, and they're also giving you n and the common ratio r. So let's take a look at our formulas for a geometric series. So those are our 2 formulas. And which one could we plug in all 3 bits of information? Well, the S of n, we already know the answer is 1,488. So you would put equals 1,488 or equals 1,488. So you could use both of them so far. Then you have your n, which is the number of numbers. There's only 5 numbers. So you could plug in the 5 right there. And you could plug in a 5 right here, but that would mean a sub 5, which would technically mean you'd have to be able to find your last term, and you can't. So you're kind of stuck with this first one where you plug in your S sub n answer right here. Your a sub 1 you don't know, but they do give you a common ratio 2, and they do give you a n, which would be the power of 5 right here in this case. And down here, the common ratio 2. So we're going with this one because all 3 things could go into that formula. Let me highlight it so you can make more sense of it. The 1,488, that's going to go right here. And then you're going to plug in your a sub. Actually, the a sub 1 you don't know, but the n you do know. The n is 5, and that's going to go up here. And the common ratio is 2. I'll do that in green. Common ratio 2 goes down here and down here. So let's do this. Let's plug it in. We have the S sub n, which is 1,488 equals a fraction with the minus sign up here. A sub 1, we don't know. A sub 1, we don't know. But we do know that common ratio is 2, so you're multiplying by 2 right there. No, I'm sorry. Yeah, common ratio 2, and then to the power of n, which is 5, power of n, which is 5. Then it's still over 1 minus r, 1 minus that common ratio 2. Okay, so I highlighted it so you could see where we plugged in what values. So this is an equation that could be solved because it has only one type of variable. It has a sub 1. Okay, now we have to use some factoring methods to be able to solve for that a sub 1, which is a little tricky, but you should understand it when you see it. Let's first start solving this by doing whatever math we can. So obviously 1 minus 2 is a minus 1. So I'm just going to replace that with a minus 1. Okay. And let's say you don't want this minus 1. You don't want this divided by minus 1. So you could simply multiply both sides by minus 1. Multiply by minus 1 cancels out. Multiply by minus 1, and you get a negative 1,488, equaling a sub 1 minus a sub 1 times 2 to the 5th. What is 2 to the 5th? It's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. So this guy right here is really a times 32 instead of a times 2 to the 5th. So now at this point, you're thinking, how am I going to get a sub 1 by itself if there's 2 of them, right? Now, let's keep in mind that when you say 32 times a sub 1, that's really 32 a sub 1. So you know what? Let me rewrite this one more time to make it look a little nicer. We're just going to rewrite the whole equation over again. Negative 1,488 equals a sub 1 minus 32 a sub 1. From here, you would actually subtract one of these a sub 1s, take away 32 of those a sub 1s, and that would leave you with negative 31 of those a sub 1s. And it's still equal to negative 1,488. Okay, and then after that, you simply get rid of the multiplication of negative 31 right in front of the a sub 1. That'll cancel it out. And we do to one side, do to the other side. So with the calculator, negative 1,488 divided by negative 31, you get a positive 48. So this gives you a positive 48. That is equal to a sub 1's now by itself. And that's what they want you to find. They want you to find a sub 1. Read the instructions. It says, given the above information of the geometric series, please find a sub 1. We just found it. A sub 1 is 48.